Okay, so today we're going to be doing another sketching of a function, also quadratic functions, very similar to that last video, except this one is a little more, well, it's a different way of looking at the formula, right? This is still a quadratic function, but before we use the vertex form, this is just a standard form of that, of a quadratic function. So it's a little bit more tricky. You have to know a couple more formulas, but they're really simple. There's a couple ways that you could solve this. One is literally converting it back to vertex form and doing it from there. But there's less a way where you use less effort, and it's just simpler to get the solution. So we're going to be doing that one first. And I mean, let's just go, right? So first thing we need to look at is what this function is, and that's standard form, which is ax squared plus bx plus c. Now, what can these different numbers tell us about the function? First off, bx is really not that useful most of the time. Sometimes you can, this case, you could actually make use out of it, but that's a little more complex. I mean, in this case, using these numbers, but it's really not that useful to graphing it. The bigger use are going to come from the a and the c. Starting with the c, what the c is going to be the y-intercept. So we know that this function at some point is going to cross y, which I don't have here, but it's about there. It's going to cross y equals 9, or 0, 9, using coordinates 0, 9. The a, we can get a couple of things, like how much the parabola opens, but that's not very visual. The main thing is going to be the positive or negative sign. So if it's positive, it opens up. If it's negative, it opens down. And I mean, here we can see, as I said, the 9, and it's positive, so it's going to open up. It's going to be something like this, right? So yeah, the way we want to start about this is we have to know one main formula, which is how to get the x coordinate of your vertex. That's going to be negative b over 2a. And that's following these letters, right? So negative b here, we're going to take the 6, because that's our b. So it's negative 6 over 2a. This has a hidden coefficient of 1 back here. So that's just 2 times 1. It's 2. Oops. So it's 2, which is equal to negative 3. And that's our x coordinate of the function, right? The x coordinate of the vertex, which is this right here. Somewhere in that line, we're going to have the vertex. So how do we find the y? It's simple. We just plug it back into the whole function, and we can get the y coordinate of that vertex. So negative 3 squared plus 6 times negative 3 plus 9. This simplifies to 9 minus 18 plus 9. That's 0. So that's our x-intercept. That's great. So we know that the vertex is over here. Now we can use a couple of different, call it facts about the quadratic function to figure out where another point here, not parallel, that lines up at y equals 9 is. It would be 1, 2, 3. It'd be around here. So we can kind of already see the shape of a parabola, but I'm not going to do that. I'm going to now you have to plug in numbers. It doesn't get any easier than this. And so we already have one number here, so let's just use, let's just plug in a couple numbers. So let's take f of 0 and f of, I'm not going to do 4 numbers this time, f of 0 and f of, oh wait, we already have f of 0. We know that's it's 9, right? Okay, well, that makes it easy. So let's just write that down. But let's then do f of, let's say, negative 4, and then f of f of negative 2. Let's make something simple. And I'm going to actually change this to f of negative 5. And you know what? I'm gonna do f of negative 6 too. So to find these, we're just plugging it into this original equation right here. So the first number I had was f of negative 5. F of negative 5, we're going to plug it back in here, so it's going to be negative 5 squared plus 6 times negative 5 plus 9, which is 25 minus 30 plus 9. That's negative 5 plus 9, which is 4. So we know negative 5, there should be a point there. Now f of negative 2 is going to be, well, let's figure that out. I'm just writing anywhere here. Negative 2, you're going to have negative 2 squared minus, or sorry, plus 6 times negative 2 plus 9. Oops, that looks bad. Okay, which is 4 minus 12 plus 9, which is 1. Let me double check. Negative 8, yeah, okay. So, oh, I forgot to write the other one down here. So this is 4, and then the other one was, we said 1. So f of negative 2 is right here. It's really close. And let's do f of negative 6. So negative 6 squared plus 6 times negative 6. Oops. Plus 9. So it's 36 minus 36 plus 9. And look at that. That's 0. Whoa. That's 9, which is the same as f of 0, which I said before, right? How did I know that? Because the points at the same y coordinate of a parabola, of a quadratic function, they're going to be equidistant from the vertex. So what that means is any point here, like I could take f of negative 5. I know that the point at the same y level of f of negative 5, meaning y level 4, right? The only other point over here will be at the same distance that negative 5 is to the vertex, which is negative 3, the x coordinates of it. So that's 2, right? We see 2 boxes here. And so we go 2 to the right, and at this right here, at negative 1, it should also be that same y level. And the same applies here, and the same would apply to any other point that we get here. So now all we have to do, we have enough points to be able to plot this. We just connect them all. It's not going to be perfect because, to get it perfectly correct, you'd either need 1,000 points or a machine to do it. But this is a good rough estimate. And there you go. You just graphed a quadratic function using the standard formula.